Welcome to the poster presentation, Volumetric Communication for Remote Assistance, Giving CPR. My name is Manuel Reber. I'm affiliated with American University and Graz University of Technology. This research is a collaboration between Graz University of Technology, American University, and George Washington University. It is supported by the National Science Foundation. The goal of our project is to build and evaluate augmented reality assistance for CPR emergencies. The problems with cardiac emergencies include not everybody is well trained on how to react in such situations, and it could happen in everyday life when no doctor is present. Applications for our work include remote medical training, and when AR becomes more widely available in the future, remote medical emergency assistance. A quick overview of our augmented reality real-time communication system for remote CPR assistance. The two actors involved are the local first responder and the remote expert. Let's start with the views. The first responder has a direct view on the local emergency procedure. Additionally, he gets guidance from a remote expert through augmented information. The remote expert has a view of the procedure and annotations through AR. The data communication is visualized by the arrows in the middle of the diagram. The first responder sends volumetric capture and annotations to the remote expert. The remote expert sends gestures and annotations back to the first responder for guidance. To allow for communication, the following devices are needed. At the local first responder, RGB and depth cameras are needed to capture the volumetrics. A head-mounted display is used to provide augmented information to the field of view of the first responder. Additionally, markers are required for alignment. A communication computer establishes and handles the data communication. On the remote side, a head-mounted display is needed to augment information and also a marker for alignment. We show a quick example of how augmented communication can take place. The first responder is guided by the remote expert through visuals. The visual communication includes hand gestures such as pointing, annotations such as 3D objects, and drawing on the surfaces. We develop our prototype using the following devices. The local first responder and the remote expert communicate through the Microsoft HoloLens 2 head-mounted display. The 3D scene is captured using the Microsoft Azure Kinect camera. We deploy a remote server for issuing the connection between the two communication parties. We design a user study to evaluate our augmented reality communication prototype. We simulate a real emergency as close as possible. Therefore, our first responder is uninformed about what type of emergency they are facing. We use a CPR mannequin that provides us with an objective measure on how the first respondent is performing. We compare the performance when using our augmented reality system against emergency guidance via phone and video communication. We evaluate the technologies looking at three different aspects. Firstly, we have the objective measures from the CPR mannequin. Secondly, we're looking at cognitive load using NASA TLX and SimTLX instruments. Thirdly, we also develop our own AR-specific questionnaires to get in-depth feedback of the AR system design. This brings us to the end of the presentation. We propose an augmented reality system for medical emergency assistance. From a technical perspective, we focus on real-time communication using volumetric information. We utilize widely available consumer devices. We also compare our AR system against traditional emergency communication technology in our user study.